Dear students, in this session, we'll learn about nomenclature of organic compound. Nomenclature of organic compound, that is naming of organic compound. Naming. So in nomenclature or naming, few trivial system, common system of nomenclature. We are practicing with the trivial or the common naming nomenclature of organic compound. In olden days, they used to they used to uh, identify, they'll be using the IUPAC nomenclature. Instead of IUPAC nomenclature, they were not knowing IUPAC nomenclature, they'll be using common name. Example, acetic acid, acetic acid, and formic acid, formic acid. Next, butyric acid. These names are used based on the Latin word acetic means vinegar. Acetic means vinegar, and formic means in the Latin that is red ant. In butyric means the butyrum, that is butter, that is butter. So with the using of this, the meaning of that word, they used to identify the compound in earlier. But after that, International Union of Pure and Applied Chemistry, IUPAC, that committee suggests suitable name for the compound, all the compounds in a chemistry. So we'll learn about the organic chemistry, IUPAC nomenclature in organic chemistry. To write IUPAC nomenclature, we need to follow the steps. Which are the steps we need to follow? First one is root word. We need to write the root word, the first word, basic word. To that root word is attached with the next to the root word, what will attach is suffix. Before the root word, what will attach is called prefix. When we split the word of prefix, it is prefix. Beginning, we are fixing to the root word. Suffix. Sa is later. Suffix. After that, we'll add to the root word. The word which is add after the root word, fixing after the root word is suffix. Prefixes will be having primary suffix, prefix, and secondary prefix. And suffix will be having primary suffix and secondary suffix. So this, with the taking of example, will come to know that the root words, prefix, suffix, primary prefix, and primary suffix. Root word that represents the carbon number. Root word is always same. If carbon number 1, root word is meth. Carbon number 2, root word is eth. ETH. Root number means 3 carbon, then the root word is prop. If carbon number 4, the root word is but. If carbon number 5, the root word is pent, and so on. So this root word will not change, always fix. Always fix the root word. To this primary and secondary prefixes. Primary prefixes, it indicates whether the carbon chain is cyclic or acyclic. So primary prefix, what it indicates? Whether this carbon chain is cyclic or acyclic. Cyclic or acyclic. If the carbon chain is cyclic, then it is using a prefix of cyclic, otherwise we are not mentioned. So the secondary prefix, which indicates the name side of the chain, substituent present in the chain. Name, side chain, name of the side chain name, or substituent or parent chain, what is attached to the main group, what is attached to the parent chain, that is substituent to the parent chain, or other group attached to the chain, which is called secondary prefix. And suffix later, which is having the two part, primary suffix, secondary suffix. Primary suffix indicates whether the carbon will be having carbon-carbon single bond, double bond, or triple bond, saturated or unsaturated, carbon-carbon single bond, saturated, carbon-carbon double or triple bond, unsaturated. From this, we can come to know. Secondary suffix. If the secondary suffix is the functional group attaches to that, functional group attaches, example, alcohol, that will be add a suffix, secondary suffix of OL. To that root word will add OL. Next, if it is CHO aldehyde, suffix is AL. Ketone, C double bond O, suffix is ON, like that. So we need to follow the steps. First is the steps, root word to that prefix and suffix. So with the writing of IUPAC nomenclature, we'll completely come to know that the organic compound, whether it's single bond, double bond, what are the functional group attached, and everything will come to know that. So we'll see that which are the prefix and suffixes, prefix, suffix, and we'll be using a word of primary, secondary, 1 degree and 2 degree. We'll see all those, what are the primary, secondary, 1 degree, 2 degree. These are the root word. These are the root word. Root word for this carbon number 1, 2, 3, or etc. So for this one, carbon number 1, meth, eth, pro, but, or pen, or etc. Root word is fixed. And in the case of secondary prefixes, we'll be having any group like methane, ethane, propane, butane that will be deficient of one group, CH4 less than 1, CH3. Methane is pronounced as methyl, ethane is written as ethyl, propane is written as propyl, or etc. Okay. And in the case of, if the functional group is present, functional group is present in prefix. If the functional group, more than one functional group, the priority will goes. If it present in the prefix, example, alcohol OH, will be using OL when the root word, after that the root word is the suffixes. In case this OH group, more than one group, which will be greater priority than alcohol, then example, carboxylic acid, COOH, will be having more priority, that is oic acid. If the two groups are present, this will be goes to root word, after the root word, suffix, then OH group comes to prefix. In such case, this OH group will be add using a word of hydroxy instead of OL, and become hydroxy. If it is aldehyde, OL, no, OL is a root word. If it is prefix, secondary prefix, then it becomes formyl. Then it becomes formyl. If ketone, in root word, if it will be present, then it is ketone. After the root word, suffix is ketone. If it is prefix, ketone, that is, we use a word of oxo, OXO, oxo. Okay, like that, we'll be writing the IUPAC nomenclature. 1 degree, 2 degree, 3 degree. So we'll write 1, 2, 3. So 3 carbon. 3 carbon, if this carbon attaches to other 2 carbon, this is called isopropyl. Right? 1, 2, 3, isopropyl. So if benzene attaches to this, isopropyl benzene. Okay, then 1, 2, 3, 4. 1, 2, 3, 4. 4 is carbon, butane group. In this less than 1, butyl, 1, 2, 3, this position, secondary butyl. Secondary butyl is also called as 2 degree butyl because 2 carbon attaches to 2 carbon. Next, if it attaches to 3, 1, 2, 1, 2, and 3, so that is isobutyl, isobutyl. And this one commonly known as tertiary butyl, carbon will be consisting 3 other group, tertiary butyl. 4 other group, quaternary, or this also be called as neopentyl, 5 group. Okay, so 1 degree carbon attaches to any other carbon or doesn't consist any carbon or will attaches to one carbon, then it is 1 degree carbon. If it attaches to 2 carbon, then it is called 2-degree carbon. If it attaches to 3-degree, means 3 carbon, 1 carbon, 2 carbon, 3 carbon, 3-degree. So carbon attaches to 4 other carbon, then it is called 4-degree. 1-degree primary, 2-degree secondary, 3-degree tertiary, 4-degree is quaternary. So before starting the IUPAC nomenclature, we should know this. With the knowing of this, we can able to start the IUPAC nomenclature. First one, rules for the IUPAC nomenclature. First one, longest chain rule. In longest chain rule, in given compound, you need to identify which is the long chain in that carbon. That long chain itself we call as parent chain. You can observe here this one. So out of this 1, 2, 3, 4, 5, 6, 7, right? So 1, 2, 3, 4, 5, 6, 7. So 7 carbon in straight chain, long chain. Whether this also can be considered as 1, 2, 3, 4, 5, 6, 7. But what happened? The long chain has to be considered. First one, longest chain need to be considered. Then the branching, if it is longest chain, this is longest chain compared to this. Okay, so this will be considered. If we consider this longest chain, this is also correct, longest chain only. Okay, root word is same, root word is same. So here also we can consider same chain. Instead of this, we can also consider this one from here to here, the same, the long chain. We need to consider whether it is straight or bent. That should be long chain. This is also correct and this is also correct. So long chain we need to consider. What about this one? We can consider only this one. 1, 2, 3, 4, 5. See 5. This is wrong. So that should not consider. We need to consider the long chain. First one, long chain we need to consider. Second one, if the two chain of equal length are possible, then chain with a more number of substituent or side chain selected as parent. See this, these two are example. In these two, I'll take a pen. Okay, in these two, 1, 2, 3, 4, 5, 6, same 6 number carbon. From here, 1, 2, 3, 4, 5, 6, both are same. What is the difference between them? What is the difference between them? In the longest chain, which should has more substituent group, the long chain should be consist more substituent group. 1, 2, 3, 4 substituent group is the first one. In the second one, we'll be having 1 and 2 substituent group, and this one 3 substituent group. So this should be correct. This is wrong. This is wrong. Why? Because the substituent group, more number of substituent group should be present in the long chain, that is preferential. If the two chains as equal length, then the possible chain with a more number of substituent should be considered. Are you getting? So this is the correct one, not this one. Okay, so long chain you need to consider. If it is both will be having same number, you need to consider the which one has more substituent. Next, lowest locant rule. The carbon atoms of a parent chain number, such as carbon carrying the side chain, gets a lowest number. So which of this? Both are, if it is 1, 2, 3, 4, 5, 6, 1, 2, 3, 4, 5, 6, will be having the same number, carbon, right? This is also same, this is also same. Then why this is correct? Why this is wrong? Why? Because from substituent group 1, 2, 3, if we are naming from this side, methyl group will be getting the least number. If you are naming from this 1, 2, 3, methyl will be getting, okay, methyl will be getting 1, 2, 3, 4 from this side, 1, 2, 3, 4. Methyl will be getting the fourth carbon. Carbon number 4 is greater. Are you getting? So out of this, substituent group should get the least number. Substituent group, methyl group will be carbon number 3, least. And if it is 4, this is more, greater. So we need to be considered the first one. This is correct. Okay. The next, lowest sum row. This is locant, lowest locant, which is having the lowest number. Substituent group should be consist. The lowest number is correct. The lowest sum rule. There are more than one substituent group. Then the number of carbon is done in the sum should be a lowest. Take these two, first one and second one. Out of these two, in first one, if we give number from this side, 1, 2, 3, third carbon and fourth carbon. So 3 plus 4 is equal to 7, right? Similarly, give this from this side, 1, 2, 3, 4, 5. 4 plus 5 is equal to 9, which will be having a lowest value. So this is correct. Lowest sum rule. The substituent group will be getting, if more than one substituent group, we need to add the position of the carbon. 3 plus 4 is equal to 7, then it is preferential. This is considered. From this side, 4 plus 5, 9, this is highest. So lowest sum rule. Lowest sum rule, more than one substituent group. We need to give a number in such a way that that sum should be lowest. And we need to consider the carbon from which side, which sum should be the lower, and that carbon we need to consider. Are you getting? Lowest sum rule, lowest locant, for that only one substituent group. Lowest sum, we need to consider more than one substituent group. When the same substituent present in two or more times, two are different, there is CH3, 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 CH3. If the same substituent present two or more times, it will be indicating by adding prefixes like di, tri, tetra, or etc. For this one, 1 and 1, 1, 2, 3, third carbon and fourth carbon, 7 substituent. So this will be considered. That is a correct one, right? For this one, how to name? How to name? For this one, 1, 2, 3, and 4, 3 plus 4, 7. So third carbon and fourth carbon, 3, 4, 1, 2, 2 methyl group, no, dimethyl, carbon number 7, heptane. 7 carbon number 7, heptane. If it is this side, 4 plus 5, 9, we should not consider. And also 4, 5, dimethyl heptane, that is wrong, we should not consider. Sum of the locant, sum of the locant. Here, if we consider 1, 2, 3. So 2 plus 3 is 5, is correct. From this side, 1, 2, 3, 4. 4 plus 5, 4 plus 3, 7. That's wrong. So from second carbon consists methyl group and third carbon consists methyl group. How many? 2. So 2, 3, dimethyl pentane. That is a correct one. Correct. Oh, correct one. Okay. Are you getting? Are you getting this? Okay, so lowest sum rule, lowest locant rule. Okay, next this one, especially for this one, you need to understand the number of carbon atoms, number of substituent group, whether 1, 2, 3, 4. Based on that, we need to identify. We need to write which will be getting the least number. Okay, next, after that, when two different substituent groups are present, at equivalent position, in the same position, then carbon atoms are numbered in such that the substituent which comes first in alphabetical order. If the 2, 3 groups will be present, we need to see the which will becomes in alphabetical order. Priority goes to alphabetical order. Okay, this one you can noticing, no, you're observing C2H5, this one C2H5 and CH3 group to the main compound, main carbon. Okay, so look here for this one. I'll take pen here. So 1, 2, 3, 4, 5, 6, third carbon C2H5, fourth carbon CH3. Out of this alphabetical order, ethyl CH3, E, which will comes first. Next, methyl, even will be giving number from this side, means alphabetical order. What's happened if we give number from that side? Okay, if we give number from that side, what it will be happen? Okay, this side, or we giving 1 2 3 4, so 3 methyl, 4 ethyl. It's so alphabetical order will be giving number from the alphabetical order. So which will comes the alphabetical order gets the lowest number. And here 1 2 3 4, 1 2 3 4. Okay, ethyl should be get lowest number. This you need to understand properly. Why this is 3? Why not from this side? Because the lowest alphabetical order ethyl, E will come first, so it should get lowest number. So that is the reason we named from this side. Okay, so you need to understand why it's named from this side. Alphabetical order we need to consider in which alphabetical order comes first, that should get the lowest value. Okay, are you getting? Next, if the functional group is present, these are the alkyl groups. No, now if the functional group is present, then the parent chain is chosen such that must include the functional group. That functional group, the long chain, in that we need to consider the functional group. Okay, so if we consider this first one in the first image, CH3, CH2, CH3, CH2, CH2, 1, 2, 3, 4, 1, 2, 3, 1, 2, 3, 1, 2, 3, 4, 5. So this is a maximum. So will be considered this one. If we consider only this long chain, there is no functional group, even though more number of carbon, that is wrong. And here 1, 2, 3, 4, 5, 6. In this one, we need to consider which one? The carbon number 1, 2, 3, 4, because it will be getting lowest number, no? Or functional group will be getting the lowest number. 4, 5, 6. Total, how many we have? The long one. So total we have 1, 2, 3, 4, 5, 6. In that the third carbon is the functional group of alcohol, oil. So total number of carbon, the long chain. So look here, 1, 2, 3, 4, 5. And for this, why we not consider the long chain? Because functional group is not included. So then why we are writing this C2H5? So here 1, 2, you need to observe here, did not get confusion. In the case of the first one and second one, so why this is correct, why this is wrong? Okay, this functional group we need to include. If we include the functional group, then it is correct. Here, if it is not any other group, then not any other group. So we can't say that 1, 2, 3, 4, 5 or 1, 2, 3, and for this only we can't stop. This is only the long chain. 1, 2, 3, 4, 5, 6. For this one, third carbon consists of functional group alcohol, fourth carbon consists CH3 and CH3 methyl group. So first, the carbon number 6, what is that? Hexane. Hexane, E is replaced by alcohol oil, in which carbon? Third position, 3-ol. Hexane, 3-ol, hexanol. 3-hexanol or hexane 3-ol. But functional group, which also consists other functional group, no, CH3 and CH3, which how many are there? 4, 4, 2, that is dimethyl hexane. Dimethyl hexane. Are you getting? Are you getting this? So we need to consider the include, the present, the choose. We need to must include the functional group. That functional group get lowest value. If we consider this chain 1, 2, 3, 4, 5, 6. Okay, hexane. In that the third carbon will be getting the CH2OH. Okay, CH2OH, CHOH alcohol. That will be considered. Are you getting this? Okay, no worries. Next, if the functional group, more are the functional group, if many functional group will be present, how the priority we need to give? Priorities give in this order. CH3COOH carboxylic acid should be greater than the rest of other. So we need to remember this. Okay, when more than one type of functional group present, then any one of them treated as principal functional group, then the rest of other treated as substituent group. One is a principal, main, suffix will be adding, rest will be add to the prefixes. And how this be the order? This is the order. First carboxylic acid. SO3H, COOR, COX means X and substituent group, CONH2, CN, CHO, C double bond O, OH, NH2, C double C. Out of this, the very familiarly will be using triple bond, double bond, okay, ammonia group, alcohol functional group, ketone, aldehyde, cyanide, okay, amides, this one, COOR, COOR esters and ethers, and COOH carboxylic acids. Carboxylic, familiar carboxylic acid will be using aldehyde, ketone, alcohols, and triple bond, double bond, and triple bond. This you need to remember. Okay, and NH2 group in between double triple bond, and in between COOH and CHO aldehyde group SO3H COX amines will be present. So you have to remember this order, okay, the priority. So the which will be getting more prior that will be present that includes in the main group or in the root word. Okay, root word that will be considered next, and other will go to the next one. Example. Here COH group is there and OH group is there. Out of this, COH is more preferential than OH group. So this should be getting first or lowest number. From this side, we are naming 1, 2, 3, 4, 5. And the first carbon will be having COH group, carboxylic acid. And fourth carbon will be having OH, substituent group. OH is alcohol. Here, the preferentially which we need to use as hydroxy. We need to use as hydroxy. In hydroxy, we'll be using OH group. So fourth carbon will be having hydroxy, 4 hydroxy, 5 carbon, pentane, single bond, pentane. E is replaced by oic acid, 1 oic acid or pentanoic acid, both are same. Okay, 1 oic acid, number that is not ONE, 4 hydroxy, 4 hydroxy, pentane, pentane. E is replaced by 1 oic acid or 4-hydroxypentanoic acid. So preferentially, which will get carboxylic acid more preferential than alcohol. Okay, so you need to name the organic compound based on this. When the same functional group is present in more than once, then it is indicated by using prefix again, di, tri, or 1, 2, 3, etc. So we'll see an example. We'll see an example to this. Okay, no. So if this carbon you need to observe, because next I'll give few questions. So if it is named for this one, you need to observe the OH group is a functional group, and here is the functional group. So two functional group will be there, that is more prior than double bond. So what we need to do? So two are there, di, alcohol, oil, diol. Okay, and which carbon from this side? 1, 2, 3, 4, or 1, 2, 3, 4. In both the side, 1, 4, 1, 4, diol is a functional group. How many carbon atom? 1, 2, 3, 4. Okay, that is bute, carbon number 4, bute. Butane, E is replaced by oil, butanol. But what happened? The double bond is there. After the root word, we need to represent whether double bond, single double bond, or triple bond is nothing but butene, or butane. This is butene. Okay, butene. So first carbon consisting ene. So how will be naming the 4 carbon atoms? Bute, double bond, that is 1 ene, butene, and that last E, butene, all, oil, all, 1, 4, diol. Before that, we'll be having another root words now, which is chlorine is there. Chlorine, in which carbon? From this side, we have given 1, 2, 3. So this is the 4th carbon. So 4 chloro, halogen will be represented as halo. So 4 chloro, CHLORO, 4 chloro, 1 ene, 4 chloro, bute, 1 ene, 1, 4 diol is a proper nomenclature. And should not be from this side. We should not give. There is an alphabetical order, sir. Chlorine will come first. C. That's a will be given. No. Functional group OH in the double bond. root word will be after the root word, primary suffix is alkane, alkane, alkyne. That should be clear first. From this side, 1, 2, 3. Okay, not from this side. So that is a proper way of the naming the IUPAC compound. We'll give one more. We'll consider another one. If you see the next one, we'll give the few of a compound. Can you able to identify? If you can able to identify, okay, first one, what is the name of this compound? From which side we need to consider? Okay, so how many carbon here? From this side, we need to count possibilities. 1, 2, 3, 4. 1, 2, 3, 4. 1, 2, 3, 4, 5. So we need to consider. We need to consider the long chain. No, we need to consider this from this side. From this side to this side. 1, 2, 3, 4, 5. Third carbon consists methyl group, right? And C double bond O, CHO is the functional group of aldehyde. So this will be 3 methyl, 3 methyl, 5 carbon atom, pentane. E is replaced by alcohol Al, pentanol, 3 methyl pentanol. Okay, are you getting? Similarly, the second one, first one is 3 methyl pentanol. See, the second one will be, should be get the lower value from this side. 1, 2, 3. 1, 2, 3. How we are getting? Okay, so this will be COOH, functional group of oic acid, right? So 1, 2, 3. 1, 2, 3. This carbon itself. For the second carbon, we'll be having the CH3 and CH3 group. So how will be writing 2, 2 dimethyl. How many carbon atoms? 1, 2, 3. 1, 2, 3. Are you getting? So here 1, 2, 3, 1, 2, 3. There will be possibility, different possibility. You need to observe 1, 2, 3. If you consider second carbon will be having one methyl group and this functional group. So functional group we need to include. So what we need to do? This should be considered some 1, 2, and 3. So 1, 2, and 3 from this side you need to consider, not this side. Okay, then it will be 1, 2, 3. So 3 is propane. Propane 1 oic acid. Propanoic acid or propene 1 oic acid. And the 2 methyl group will be present in second carbon. 2, 2 dimethyl propanoic acid. 2, 2 dimethyl propanoic acid. Propanoic acid. Okay. So that is the IUPAC nomenclature of the second one. Okay. Next, third one. In the third one, so need to consider from this one 1, 2, 3, 4. 1, 2, 3, 4. Long carbon chain we need to consider butane, 4 carbon. Okay, butane. In the butane, COCl is acyl chloride. First carbon will be consist no butanyl chloride. Butanyl chloride. And the 1, 2, 3, 4. Fourth carbon will be having 1, 2, 3. Third carbon will be having methyl group. So 3 methyl butanyl chloride. This is the nomenclature. The fourth one here. So CH3, CH3, CH3. This will be CONH2, right? CONH2 is amide as it is. Carbon number, longest carbon you need to consider 1, 2, 3, 4, 5. 1, 2, 3, 4. So we need to consider from this one 1, 2, 3, 4, 5. So fifth 1, 2, 3, third carbon consists methyl group. So we can write 3 methyl. 3 methyl. 5 carbons are there, no? Pentane is replaced by amide, pentanamide. 3 methyl pentanamide. So we can check what we written the answers. Okay, so first one 3 methyl pentanol, Al, 2, 2 dimethyl propanoic acid, third one 3 methyl butanyl chloride, and 3 methyl pentanamide. Okay, so this is for the normal. Naming of complex compound, if it is more, means 2, 3 groups are attached together, then also we need to consider the long chain. Okay, we need to write in such a way that more should get substituent group. No, from this side, how it should nomenclate. So it should be, we'll check this. 1, 2, 3, 4, 5, 6, 7, 8, 9. 1, 2, 3, 4, 5, 6, 7, 8, 9. Same. 1, 2, 3, 4, 5. This side. 6, 7, 8, 9, 10. Will be more number of carbon. So this will be considered. If they consider fifth carbon will be having the substituent group. So total number of carbon is 10. That is decane. In the decane, there will be substituent group. In the decane, there will be substituent group. Which are the substituent group? So in fifth carbon, there will be substituent group 1, 2, 3, 4, and that is butane. In that second carbon, we'll be having the ethyl, that is 2-ethyl butane. Substituent chain is 2-ethyl butane. And next, for this fifth one, after that, we'll be having no S. Yes, look here, fifth one, sixth one, seventh one, eighth one, ninth one, 10th one. Okay, here what it will be 1, 2, 3, third carbon. This is okay. This chain is okay, no problem. This substituent group, okay, complex compound, we need to be represent within a square bracket. Within square bracket will be represent. This third carbon will be having 2 methyl group. So after that, 3, 3 dimethyl. Next, carbon number 10, root word decane. So proper name is 5 5 2 2 ethyl butyl, 3 3 dimethyl butane, dimethyl decane. That is correct. So what is the wrong? How it will be? Why should not be considered other group? If we consider this one, fifth one, for the fifth one, carbon will be considered this one 2, 2. If we consider this one 2, 1, 2 and 2, this is not function, this is not separate group, this is a long chain, in that it is attaches to this. So we should not consider 2, 2. That is 2 methyl only itself, methyl ethyl group only, that is not methyl group. And next, if it comes to this one, we should not consider the same only one CH group, 3 ethyl group. That's wrong. That should be 3, 3 dimethyl group. So this is a correct. So which will be writing, the solving of the writing of the more compounds will be getting this one structure. Okay. Next, IUPAC nomenclature for cyclic compound. These are the linear. If it is cyclic compound, closed chain. Closed chain if it is first carbon links to a last carbon. Okay, 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. First carbon links to a last carbon, cyclopentane. And in the case of this compound, look here, 1, 2, 3, 4. We'll be using all these. Locate some rule, then alphabetical order, everything you need to keep in mind, and the nomenclature. From this side, 1 will be group attached to 1, 2, 3. Okay, propane group attached, methane group attached. Okay, this methane will get preferential number. So alphabetical order 1, 2, 3. Okay, 1 methyl, 3 propyl, rest of the carbon 6 carbons, that is cyclohexane. So if it is attaches to 2 ethyl group, and this one methyl and methyl group, methyl and methyl group, here methyl group and here methyl group, more number of branch chain should get lower number. So this should be 1, not this one. If it is alphabetical order is, even though it is ethyl, so more branching is here, should give number to this one 1, 2, 3, 1, 1. So 1, 1 dimethyl cyclohexane. This is a root word. To that attached branch is ethyl. In which position? Third carbon. So 3 ethyl, 1, 1 dimethyl, and cyclohexane is the name of this compound. Are you getting? So similarly, we can see other compound. And methyl benzene. Methyl benzene, this methyl and benzene is also we call as familiarly toluene. C6H5OCH3 is called anisole, methoxybenzene, anisole. So here also 1, 2, 3, 4 nomenclature should be given. Okay, this is 1, 2, 3, 4. Okay, this methoxybenzene, anisole, methoxybenzene root word anisole. For this one, second carbon attaches to this 2-chloro 4-methyl anisole or 4-chloro 2-methyl anisole. Both are same, anisole or methoxybenzene. Next, for this one, if the same substituent group are present, This this will be 1 comma 2 dibromobenzene. This also we call as orthobromobenzene. This position is meta bromobenzene. So 2 meta dibromobenzene or 1 comma 3 dibromobenzene. And here bromine and bromine opposite with each other, 1 comma 4 or 1 comma 4 dibromobenzene or para position, para dibromobenzene. So this is the IUPAC nomenclature for the cyclic compound. Along with that, nitrobenzene and bromobenzene, NO2, nitrobenzene, BR-benzene, bromobenzene, and this position 1, 2, 3, 4 out of the CH3 and methyl, OH get preferential. So OH will be considered phenol. Rest of substituent group are this one and this one, 3, 4 dimethyl phenol. And this one, and as aminobenzene is called C6H5NH2 is called aniline. Aminobenzene or aniline. NH2 group attaches to benzene. And if it is group attaches to benzene, one Cl, one NO2, one NO2, okay, and NO2 and Cl. So it should not be from this side, from this side will be given the lowest number from this chloro nitro group, okay, chloro and nitro, Cl. So 1 chloro, 2, 3, 4. The numbering has to give no from this side 1, 2, 3, 4, 5, 6, 6 membered benzene. So first 1 chloro, 2 nitro, so not 2 nitro, 2 comma 4 dinitro benzene. That should not be in reverse order, which will be gives from this side 1, 2, 3, 4, 5, or I'll write erase and right. This should not be from this side 1, 2, 3, and 4, or 1, 2, 3, 4. Should not be like this, because the more branching, more numbers should be get, the more number of substituents should be get the values numbers from this side only. From this side only. From this side means 1 chloro. C in alphabetical order 1 chloro. Next, not 1, 2, 3, 4. That is also wrong. If you give from this side, it is also wrong. 1, 2, 3, 4. 4 nitro. That is wrong. So the proper way is 1 chloro. So you need to consider everything in mind and answer. Okay, 1 chloro, 2 comma 4 dinitro benzene. For this one, so preferential. So look at the which one should get the least value from this side. 1, 2, 3, 4. 1, 2, 3, 4. Which covers more number of substituent? No. 1, 2, 3, 4. 1 methyl, 2 chloro, and 4 nitro, and the rest is benzene. So nitrobenzene, 2 chloro, 1 methyl, the nitrobenzene, 4 nitrobenzene. So this one also. So this is methyl, anisole, C6H5OCH3 is anisole. Further, the substituent group are CH3 and Cl. Second and fourth carbon, 2 chloro, 4 methyl, anisole. Next, NH2. NH2 is aniline. Further, the group are attached to C2H5 and CH3. So second carbon and fourth carbon. From this side, 1, 2, 3, 4, 5, 6. So there is more number will be getting. So it should not use from this side. So 4 ethyl, 2 methyl aniline. Are you getting? So this is how we can able to nomenclate the compounds. In next class, we'll discuss about isomers. Are you understanding? So we'll continue in the next class.